Hello, everybody.
Hi there.
We're going to wait a couple minutes to get this thing started. Probably start a little after 11, maybe 11:02. Make sure everybody's in. Hope everybody had a good Halloween. I don't know about you, Richard, but
was awesome.
Mine was very uneventful. Just ate too much candy, probably.
Yeah. Yep, folks are coming in.
Good. So, if anybody hasn't done this before, you have the ability to control your window size, so you can pick between our screen share on your screen and also looking at our beautiful faces. And make sure we're going to be switching back and forth between like talking, showing, and also showing stuff on screen, just to make sure you are in control of all that. So I think that's an important note before we get started.
Right. And you can ask questions, of course.
Yes.
Raise the hand. I think there's an option to raise the hand.
Yeah, we're gonna have a question part at the end, but we're also going to be taking questions during it. And if it's something that we're talking about, we'll try to answer them on the fly. So we can sort of, if something comes to mind, just let us know. Let's see here. So we have a couple more minutes.
Okay. Yep. A couple more people are joining.
Yep. Robin, the audio sounds okay? Everything look okay? Sorry, Robin's our, we'll call her our producer. She's watching and making sure. Okay, good. We're good. So, looking good. And if you feel like sharing this with friends or want to watch it again, we will be recording this and putting it on YouTube. So, even if you have to jump away to, do a rush case or something.
Doesn't mean to jump away, though.
Yeah. We appreciate everybody spending the time with us. All right, 11:01, maybe one more minute, and we'll get going. Get this thing on the road.
Yep.
Got everything? I think we got everything.
Seems good to me, huh? What do you think?
Yeah. We'll get started.
Get going.
Okay. Thank you, everybody, for coming. My name is Sam Wainwright.
I'm Richard Jentsch from Girrbach.
Yeah, Richard came up from North Carolina to visit me and the rest of the team here in Stoneham, Massachusetts, to give you this webinar today. And today we're going to be talking about Amann Girrbach, their product line, and everything else, but we're really going to be focusing on the Amann Girrbach Motion 2 milling machine, its capabilities, and giving a brief demo of it to show sort of the indication types and everything else. Here is an overview of our webinar, just so everybody knows. We're going to do an introduction, which we're on right now. The evolution of Amann Girrbach as the premium CAD CAM provider in the world, their portfolio as it stands, and why it really, this one piece of their entire portfolio is so incredible. And then we'll give details on the Motion 2 itself. We're going to be going over ceramic milling and features on the Motion 2, titanium abutment milling, what that's capable of, screw-retained bridge milling, or they call it the reacts. We used to call it the Iser, all the same sort of thing. And then what denture solutions they have to offer. And I know this is a top of mind for a lot of laboratories right now because it's such a hot topic. And then really briefly also the removable, partial removable, I should be specific. Then we'll be doing a demo on some CAD, just showing things around, the cam, screw-retained bridges, maybe some other pieces, maybe dentures a little bit. And then loading the machine, showing how the fixtures go in, the tools, so forth and so on at the end. And then, again, we'll be doing questions. So, yep. Richard, you've been with Amann Girrbach from 2009, right?
That's right. Since December 2009 is when I started with the company in Austria. Born and raised in Germany, moved to Austria, lived there for quite a while. And, yeah, the company evolved quite a bit. You can see that here on the chart now on the screen. In 2009, December, just end of the year, was pretty much when the first generation Motion 1 4-axis dry came out, and the MAP 100, MAP 300. Now we got the MAP 400, the 400 plus, the 200, 200 plus, a 4X Motion 2 Classic.
Mm-hmm.
The 5X Motion 2 Classic came in 2012, summer 2012.
We still have a lot of those running today. So.
Yep, and they are still great machines. The entire holder concept is a good point for how future-proof the system is. The company always has been that way and will not go away from that. All the holders what we're going to show, they are also going to be valid for the Classic Motion 2 as well.
Yes, we call it the Motion 2i, right? So this is the evolution of the Motion 2. We'll call it the Classic now. But this is the first version of the Motion 2. Before this was the Motion 1. And the reason we wanted to show this slide was to show how much has changed over the years with this mill and is really capable in this mill today. The Motion 2 DNA, which we're going to be talking about today, adds some speed and other things we'll get into, but it's just pretty amazing to show this and all the materials it can do in addition and everything else. So it's a constant evolution for the company, and it's pretty impressive. So what's next?
Yeah, and it gotten some great new updates, what we want to focus on, like a new spindle. You see that in the next couple of slides, control board. But in general, it already had such a great concept and was so versatile that there was not much what we needed to actually do on it. But those new updates will open up things like more speed, etc. See that on the next slides.
Yeah, and we'll be going through a lot of these indication types today, and I'll also be mentioning, because there's a full system with Amann Girrbach, but also if you have existing equipment, where does it fit in, what does what, and we'll try to go over as much as we can on that. Again, please, if anybody has questions, just stop us anytime. This is their all in-house wheel, where they're highlighting all the indication types materials that the milling machine and full Amann Girrbach system honestly can do.
Right.
And impressive.
And of course, they can look into a micro 4X or 5X as well if you're specifically looking into the dry mill materials. But today we want to look into Motion 2 as a hybrid mill, covering all those indications what you're not seeing on the versatility wheel.
Yes, that's a good point. Actually, you can go forward, but if it doesn't make sense to get the full sort of, we'll call it the Porsche 911 mill. You can get the I don't know what less Porsche there is, but anyway, you can get into just dry milling and something that maybe just is more specific to what your needs in the laboratory or what you need. So this is the last slide about Amann Girrbach and their full system, and I think this is really important because they not only sell milling machines and scanners and software, but they also have model solutions. Everybody probably knows the Artex articulator, right? It's famous. Everybody uses that. And the end-to-end solution. And I think if anybody's looking into, if you're not into CAD/CAM and you're looking for a premium, integrated, sort of all-encompassing solution, I think it's definitely a strong consideration for any laboratory, especially if you want to produce high-quality, consistent results. It's materials and everything. Okay.
And providing the whole workflow, not only the equipment, but also the complete workflow from A to Z. From basically the impression, like you said, going through the model, through the articulator, into our scanner, lossless, not losing the Facebook information, none of that. Being able to have the actual Artex CR, what we have analog in the software, and having the whole workflow validated and provided.
And Richard is a part of a team at Amann Girrbach USA that supports this. They're available for our customers. We are, of course, the first line of support for a lot of this stuff, but if it goes above and beyond or we feel like we're not able to answer these questions, Richard has himself and a whole team at Amann Girrbach USA, and I think that's really important. We sell a lot of things, and not everybody is invested into the USA specifically and putting this much support and this many resources for us. Right. So that will be my last point here.
And it makes it ultimately easy having the entire portfolio, basically only calling one second level. If everything comes out of one hand, it's going to make things a little easier.
Good. Okay, so this is their very beautiful full line of mills. I think we can move on, but we're talking about specifically the Motion 2, which is a 5-axis wet dry mill.
Correct.
And it's a little different than the Motion 2 Classic, we'll call it. Right?
Right. So gotten a DNA update, and the DNA, where's this coming from? The Amann Girrbach has been a machining company since many, many years, and they then ended up joining the dental market. So there have been always been and see machining involved into this, and that all has been put into the machine as DNA of Amann Girrbach.
As the structure.
Right, and the experience has really been found its way into this with the hardware, the CNC, and the processes.
Right. It's baked throughout.
Right, and this got into a next level with the new advantages of having in-house produced control boards. You can see that on the picture, where the classic machines, the control boards have not been made at that time in-house, and now with that we can really control every single piece which is in the machine and benefit from faster milling cycles.
It's really in-house. It's not only in-house for your laboratory, but it's in-house at Amann Girrbach.
Right.
So it's like direct to R&D. It's direct support to that team, product management and everything else. It makes a lot of sense. The spindle's different, right? So the previous spindle, just to sort of catch everybody up, was 6,000 RP, 60,000. Right. So it's a little bit slower. The wattage was bumped up. This new one, I think, is 750 watts. The old one was, I think, 500. Or
I believe so.
500 watts. So 50% improvement in power. The speed's almost 50% higher as well.
Right.
And all this in combination, it's a Jaeger spindle. We can say that, right?
Yeah, correct.
German made, which are very high quality. They can be rebuilt. They really should last a very, very long time with the proper maintenance.
Right.
And it gives a lot of advantages.
Right. Even the 60,000 RPM Jaeger spindle, we have machines out there. They have well over 10,000 machine hours on them, and didn't have any spindle replacement or maintenance. Of course, the maintenance with the chuck is required, and keeping
collet,
clean, right? The collet, and having good clean air. But other than that, it's good quality. And the 100,000 RPM upgrade basically was only required so that we can be faster with the carving and glass ceramic and Emax.
Yeah, and we're not really talking about a lot of dry milling other than the advanced indication type of a screw-retained bridge.
Right.
But the mill is faster milling zirconia too, and that probably has something to do with the strength of the spindle, I'd imagine, and also these other components, control board and everything else.
Control board and the spindle controller, correct.
But isn't it milling, zirconia in about 12 minutes around there?
Right.
Yeah,
pretty much. But
just single molars.
A wide variety, of course. It depends. If you have a coping, it can be quicker than that.
Right, because you're not doing the anatomy milling.
Correct.
Sure.
And now you got more and more options as well for the quality, what you want to choose and pick from. So, for example, you can choose in between standard and HD. That's a difference in between a 0.6 millimeter burr on the anatomy and a 0.3 millimeter burr. And now there's the new simultaneous 5X strategy for the outside of those large full roundhouse cases.
Which we're going to get into for sure, because I think that's a big part of this for sure. Okay.
And of course that strategy is applicable also to bridges. It doesn't really make too much sense on the crown, but on a bridge you could run into a situation where you require it, and that all bumps up the milling time, of course.
Sure. Yeah.
And we apply where it's needed. And that's part of that you can choose and pick from the correct strategy, which, by the way, are all tested and developed with the R&D team in Austria. So you can rely on the experience there that you're getting a milling strategy which is working. And if not, then we will take care of it.
Yeah, good. Yeah, this is sort of a conclusion of what we've been talking about. It's a combination of everything, right?
Right.
It's the power, it's the intelligence, it's the development to equal the performance that we need. So digging in a little bit deeper on the indication types, we start with the wet ceramic milling. And we have, maybe we should go to the next slide, but the DNA Motion 2, it's actually in the mill.
Yep, we installed it.
Yeah, so the old Motion 2, I shouldn't say Motion 2 Classic could do ceramic milling, of course.
That's right.
But it was a little bit different. It was a little bit slower. This one has some unique features to it, right, Richard?
That's right. So the Classic is the exact same holder. The concept, how the axes are aligned, with where the A, B axis is, this X, Y, and then the Z axis for the spindle. The big arm is going to be your B axis, and the blank holder itself is going to be the A axis. That is all still the same, but we get a little bit more details with the timings on the next couple of slides. The concept has changed where we used to do grinding. You can see that here in the center.
Yes.
And now have been updated to the carving due to the control board and the spindle, where we can have a unit in roughly 15 minutes versus 45 minutes.
Right. Well, and other milling solutions typically always do the middle. They're always grinding. Everything I've used in the past has always been grinding. And that's why, unless you have two spindles, it takes about 30 to 45 minutes to mill a unit. Right. And actually, hopefully everybody can see this, but you can see this is actually the block as it pops off. So it just goes around the unit and then it finishes it up. So it literally has this much less to mill. It makes a huge difference.
The pattern might be maybe different. Sometimes it's a cross pattern, but it normally is a very slow reduction of it. That's due to the material. Of course, the material is very hard, and the harder the material is, it's more brittle. So you couldn't mill it where the milling is, you got a cutting edge and you're removing the material pretty quick by that. That would chip and would not give you a good surface quality at all. You couldn't mill a margin out on so hard and brittle materials. So they're basically like sandpaper down if you want to with a grinding burr.
Yes. Right? Yes, opposed to end milling, which is
that takes time. Yeah. And on the carving, the axis is just being removed, and we are left over with a pretty good shape already from the tooth, and only have to fine tune it from there.
That's great. So take this with a grain of salt, but the fastest they were able to get a unit down to was 9 minutes. Right. We typically see more about 15 minutes. It really has a lot to do with the size of the unit.
Correct.
And also the detail of the unit. So if it's like I think like this is a pretty good example of something that's super fast, like a central.
I'm very positive that this took 15 minutes and just a few seconds.
Good.
And now it's actually back to a smaller unit is done quicker than a bigger unit.
Yes, a little counterintuitive.
Right.
Great.
So new to this is the thrilling, what we call it, where you're also not only being able to get all that speed and the surface quality. You see how nice anatomy here is being produced with the 0.4 HD tool, but also being able to make a screw axis hole wherever you want it. Good. And then I think that block on the right shows that really nicely. You can place the hole wherever you need it.
Yeah, you can do a screw retained crown at almost any divergent screw hole or anything like that.
Correct.
Well, up to a certain amount, of course, because you want to be able to get the screw in, right? I think it's like 10 degrees, roughly, is the max you can do, or is it less than that?
You can angle it. You can even have an angled screw axis hole. But I'm not quite 100% sure what the limitation of the angulation is. I just got in the debate on it.
Yeah, good. And I think it also has to do with the hole size, so the neck of the screw can go down and in. But it's impressive.
The benefit of this, of course, is that the block with the pre-milled hole is about twice the price. And
so this is using a standard block.
And you wouldn't have to purchase them because you can just mill the hole wherever you want it.
Right. So no secondary inventory or anything like that.
Correct.
So this works on nanocomposites as well?
If they're strong enough.
So will it be dynamic?
The dynamic should work, but the Vidamark 2, for example, they would probably not strong enough for a screw retained crown.
So probably not Lava Ultimate.
Right.
Not Lava Ultimate. What else is there? The Suprinity. Probably the Celtra Duo is okay, right? Should be okay. Gladwell Obsidian, which is strong enough. So just make sure you match up the indication types.
And you're skipping a calibration process here too, because if you're purchasing the blocks with the hole, they have to be aligned perfectly with that hole where the software knows, okay, this is perfectly lining up with where you designed it. So you're being limited, and you're actually ending up having to invest more time to get this calibration done. And for us, once the machine is in your calibration, which normally is, just pop the block in and you're good to go.
Okay. And the last piece is 2 holders. The one with the sort of tooth-colored crown is the AG fixture.
Right.
And then it can use the CEREC, they call it the universal mandrel, excuse me, as well, which is important. Okay, good.
There's a different holder too, which unfortunately we don't have here to show. But there's a Christmas tree holder with 12 units what you can add on to.
Yeah, so 12 units, overnight milling of a lot of Emax all at once. This is the one that comes standard with the ceramic kit with the milling machine, so 3 at a time, which is still, I mean, if you're doing 15 minutes a unit, it's 45 minutes of milling. I think that's a good amount of production to jump back and forth.
And the holder change is pretty simple too. We can maybe after the PowerPoint also show that. Right?
We'll show the change and how the tools work and everything else. Next is titanium abutment milling in-house, so using a prefabricated blank. We actually have the fixture down here, but it is pretty neat. If you go to the next slide, and we can put it in and out if people would like to see it, but it actually is rotational milling, unlike a lot of other titanium preform abutment solutions where it really does one side and then it flips over and does another, and then there's always the sort of equator line on it, which this actually spins as it mills, so it really produces some incredible stuff.
Actually, and it's less wear on the machine, of course, since it's the technical term is rotary milling, so it's a combination out of milling and working as a lathe.
Yes.
Where this is less wear and tear on the machine. And we're being able to have a really good surface quality, no equator line, like you mentioned, in roughly about 20 minutes.
Yeah, hopefully you guys can see this, but this is, I'm not sure this one. So this is an abutment milled, and you can see there is still a sprue on the top of the abutment, but this is surface quality right off the mill. It's pretty impressive.
Right.
And then to show sort of the detail and what it's able to do, this is a skull milled on the unit as well, which it's got some pretty impressive detail, and the accuracy is to the interface is really pretty incredible. So it does a really good job of centering it every time. Was that okay on camera?
Yeah. Seemed okay for me. The other benefit of this is the cap, which is here mounted on that holder, has a sleeve underneath it, which is only calibrated once. So on other systems, you have to, whenever you switch from zirconia to titanium pre-mills, you have to calibrate it to make sure that that screw channel and the interface is on the correct spot where it needs to be in order to be precise.
Got it.
And for us, we need to do that calibration only once, and the holder is precise enough to be swapped out, and it's still going to be exactly on the center axis.
So really switching out from this to this in the machine, there's no additional calibration. You just pull this is the 98 millimeter fixture going into the titanium fixture.
Correct.
There's one screw, it tightens down. Because of this advanced sort of initial milling of this holder, never has to be done again, which is really nice. I've seen other solutions where there's super advanced calibration procedure, or they'll even have, and this is a long time ago with a mill in our milling center, but had a ruby tip probe that actually sensed, and it would go around and touch the blank, and it would be like this, almost like a blind person would find and feel where an object was, and it was incredibly complicated. And I remember one time, sorry, this is my last, just one story quick. It actually would drive into the holder, this ruby tip probe, and it was like $500 to replace it, and it happened twice to us, and we're like, man, I don't know if this is really a great solution, but it was super early on in the blank milling process. I think this is like 5 years ago now. Anyway.
And that concept of that holder change is throughout the other holders as well. So some require no calibration, the others don't. So the titanium Typeform holder requires calibration. The D-flow holder for the denture teeth, what we will show in later a little bit, that requires calibration, but it's always only once. And then you can really work how your workflow is throughout the day, and switch back and forth from the holders, and depending how you get the cases in, and the due date is, and not according to how much time you're wasting for calibration.
And so before we get to indication type, the output from your Amann Girrbach Ceramill Mind obviously works with this. We have a connection with 3Shape, so even if you have an existing 3Shape scanner, you can build custom abutments. Is generic ExoCAD work with this workflow?
It does.
Okay.
Any open system, really. I mean, the most popular one of which is ExoCAD, besides Ceramill, of course. But as long as you have an STL file or another open format file, now newly going to be in the future, I think the PLY is going to be a more open topic since you can replicate texture on them. But as long as you have an open system, it will work with this.
Okay. I probably wouldn't count on Sirona or Dental Wings working, though. Let's just stick to the ExoCAD Mind and 3Shape for now on this one.
But you can import any open STL file from intraoral cameras if they're being spit out, like a Carestream 3600.
In the Mind software.
In the Mind software, correct.
With scan flags, and I think I believe it's anti-trading scan flags.
Right.
Right.
But you can integrate different libraries as long as they're ExoCAD compatible.
Okay. Good. All right. Next is the indication, or sorry, implant interface supported types. Astra, 3i, one of the dense ply types, Nobel, Straumann, not bone level, just Sonata, and then Zimmer.
And there's soon going to be a update available where we also have the Medentica library integrated.
Oh, okay.
So that's going to be the official solution, but like I said.
And that opens more, right?
Right.
Do you know what that adds? Does it add...
well, I think the one thing where a lot of people have been looking for is taller tie bases. And they are going to be in there, and there's going to be a couple more systems in there as well.
For the titanium prefabs?
The titanium prefabs, I think there's a few more added to it.
Okay.
But
I'd like to see, hopefully it's bone level.
The Straumann, we're waiting for the FDA clearance, but then also Straumann original blocks will be available for this.
Oh, so OEM parts.
Straumann original, correct.
Cool.
So that's exciting.
So for today, this is all we got, but in the future, again, we're adding to these indications for the future. Okay. Good. Next is the screw-retained bridges, or the Reax bridge, Amann Girrbach calls them. But this is all on 4 fixed.
Right. Big topic. More and more people request this. A lot of people have been already playing with this around. Same thing. If you design it in 3Shape, you can import it. You can process it in the CAM software. Or, of course, you can use our engine module. I do have a CAD file loaded up.
Cool.
Where I can show a little bit about benefits of it.
I think we have a slide on that, too.
Right.
Which is, and I guess the important point is that even if you design this in 3Shape, ExoCAD, Dental Wings, this mill is going to be able to give you, I think the next slide shows it, be able to mill these types of indications. So, yeah, perfect. So this is, even if the CAD on this is different, you're still going to be able to put it into the CAM.
Right.
Internal and external 5-axis.
Right.
You're still going to be able to use Amann Girrbach materials, or of course it's an open system, so if you prefer others. And then it goes into the machine, and then your standard workflows from there.
Right. And that's a good example to see how Amann Girrbach ties everything together in one package.
Yes.
So from the start, from the get-go, you throw the CAD, through the CAM with the 5-axis, including with the material. The material selection is important for those large cases. The HT Plus just came out, for example. So all those things are tied together, and we can help you to get a good quality end product.
Yeah, and I always recommend 11, I'd say maybe 1,000 to 11 megapixels plus on these types of bridges. And always check your connections between units, and not too much cantilever either.
And you get great time savings, since I want to say the 2 most important for me are that you're able to design the gingiva, that you don't have to make a denture setup basically which you're converting. You can design it right away in your prototype. Yeah. And the other biggest time saver is the cutback library. Yep. Where you can purchase the Knut Miller cutback add-on for your existing Knut Miller library, and then you can choose from 3 different cutback types. On the Mind software, the CAD software. Right. So you don't have to invest the time of making a manual cutback, which you can, of course. And you can do a provisional try-in. Right.
just out of PMMA or even wax if you just want to send that to the doctor or the, or whoever. Yeah, this is talking about the Engine, which just came out for the Ceramill Mind.
Right.
CAD software, which is a necessity for these types of cases where you can, it can be full contour or cut back like this, but the important part is having the gingiva come into place with just drawing the perimeter, really, right?
That's pretty much it, right? And then you can freeform it and take it from there. And here's actually a good example on screen from that cutback library. It's one of those 3 types.
And you can set the thickness, so if you wanted to layer more or less pink.
You can change the shape of it, and you can even freeform on that. So if you wanted to do some minor changes on it, then perfectly fine to do that.
And always checking thicknesses and everything else.
Right.
Because the strength of these bridges really comes down to the thinnest part of the connection. So especially with non-metal.
Right.
Yeah,
no, those cases are not easy. There's a lot of things to consider. The right sinter program, not only the material, but the correct sinter program, stabilizer, all of those things. And yeah, we can help you.
Definitely an advanced indication type.
We can help you A to Z through with the workflow.
Great. This is a great example of external 5-axis milling versus non-external. And what it really means is it's able to pivot and rotate the fixture in a way where it can get to these undercuts on these restorations. And the bottom one is a mill that maybe has internal 5-axis milling, but not external. So it's really just less post-processing. It's less by hand, less time at the bench.
That's right.
Which everybody wants.
That's what it comes down to. And if you're milling in such a case overnight, then the extra milling time doesn't really matter. And you're free to do other things while the machine's giving you that fantastic result.
Yeah, it adds a little milling time, but it's well worth it. Especially it's hands-off time. This is also true with the Micro 5X, correct?
That's true. Micro 5X, same strategies for that available.
Great.
And it's your decision to choose from standard or HD, meaning a 0.6 or 0.3 tool, and if you want that 5X milling on the outside.
Got it. So it's really, you can pick and choose. So this is a beautiful case done by Amann Girrbach. This looks layered, but it's beautiful.
Right.
Dentures, which I'm going to rely a lot in you, Rich, because this is, as everybody probably knows, dentures is like, it's changing so much. There's so much going on. It's almost hard to keep up with everything that's going on with dentures. But Amann Girrbach has a couple solutions that are really, really interesting. And I should mention, all these are only possible right now with using the Mind software, right? So MAP 400 Mind going in through their Denture software, which is very, very good, and then coming into their milling machine. And this is Motion 2 only?
Right. This is for the Motion 2 5X only.
So no micro. Okay, perfect. Good.
And especially with the new added indications, you need the some materials wet milled, and this is one of the benefits which we haven't spoken yet about the Motion 2, that you can switch in between wet and dry depending what material needs it. The Micro 5X is a dry mill only. The wax preferably we mill wet. For the dentures, since it's a very soft wax and not a milling wax, and the teeth are being wet milled. And yeah, there's some exciting updates for this as well, where it's adding new capabilities to it.
Yeah, we haven't talked about it very much, but switching from wet to dry in the Motion 2 is the easiest I've ever worked with, and I think industry-wide it's got to be one of the easiest systems because it has all the fixturings, it has all the parts and pieces that switch and are specific to either dry milling or wet milling.
Right. So, and that's opening the whole removable and denture, full denture is opening a whole nother door for those combination of the different modules where we will see a lot of cool things happening in the future.
And I think this is one of the strengths of having an integrated system. You can be really cutting edge with this stuff. Whereas, these systems where you sort of get one piece and another, yeah, it'll get it maybe, but it will probably be a couple more years before they get caught up with somebody that really controls the whole process.
Right.
So this slide is just really going over. We already talked about fixed. We're going to be talking about removable dentures as well as some partials in the end. And then in the future indication, which actually looks really interesting, is a hybrid of possibly having a bar maybe in Syntron, maybe
Correct.
maybe like a peak material, maybe
Right.
one of these
That's
acetal, these new really flexible, amazing.
Correct.
I don't want to call them plastics because I don't think they are.
Mhm.
But and then having a denture over, so it's a the patient's able to pull them off and clean them and have them, much more secure.
Yeah, and there's already a lot in the works, and I just looked at the new beta from the partial module, like you mentioned it. It's workflow is good. It's all fully integrated.
So in these hybrid combinations, we should expect probably 2018 sometime.
Right.
Probably Q.
Right.
I actually don't want to say anything, but 2018 future indication. Always working on something which is awesome. Yes.
Yeah, so back to the full Dentro Systems very quick. You already know the FDS system has been on the market now since quite a while, with the Pala teeth being used.
Mm-hmm.
And
just to be clear, that's the bottom one, right?
That's the top one.
Oh, I'm sorry.
Yep. That's
oh,
the top
FDS,
one,
I'm sorry.
right, which says the FDS, where you, like you mentioned, you're using an Altix articulator, you're scanning a MAP 400, you're making the design of upper-lower denture.
Mm-hmm.
You can bring in an old denture scan if you wanted to, change things around, or adapt it to the looks of the old one, and digitalize it, do a base out of wax, what you just showed, right? And mill the teeth base if required.
And I think we have some photos in the next slide. We keep
Right.
going.
Put everything together, make a try-in, and then you go to the conventional fabrication and finalization of those. What's new now is the Vida Corporation, which is currently only possible in the Amann Girrbach system. Not quite sure how long that's going to stay that way, but it's currently we're the only one where that's integrated. Yeah. It's probably going to stay for quite a while that way. And also the Baltic Dentro System has been integrated. So we got now 3 systems where you can pick and choose from, where you should really be able to cover most, if not all, of your cases within. And the Baltic Dentro System is a very quick way. You can see there's something not required in there, so we don't have a try-in necessarily, which needs to be done. And there's going to be a couple of appointments being just knocked out where the impression taking, the bites, all that is established in one meeting. Mm-hmm. But the patient eventually not always fits into small, medium, and large, what the concept is. Mm-hmm. The Baltic denture has a blank available. We see that then where the teeth are already in place in the resin part, mm-hmm. and only the base is being milled out. So that's why you're saving a whole bunch of time with it. If the patient doesn't fit into the concept, then you now still have the bionic, mm. where you can still make a same concept, now with Vida teeth, a milled wax base, mill the teeth from the basal and then put them together. Or you can also skip the wax if you wanted to and mill it directly out of a resin in a 98 millimeter puck. And finish it.
A tooth-colored resin.
Right.
Why?
No, that was a pink
I
colored resin.
I see.
Right. And new also, which is I think fantastic, is you can mill the base together with the teeth out of a white wax and make a try-in mm-hmm. with that. So you can confirm that your setup is okay, that the patient's happy with it, and you're not milling the teeth already right. and finding out the patient's unhappy with the shape or something like that.
Right. Once you mill those teeth, it's hard to go back.
Right. You can. I mean, you can still use them for an analog setup, but since if they're out of the blank, then
right. Once they're out of that blank, that's right. You can't put them back in the machine.
And that's step in between for that reason makes a lot of sense.
Got it. All right. So
we see a picture here. They are color coded, and the nice part about this too is for the folks which might already have this out there on the Pala system and or the FTS system, this will most definitely bring the price down for the teeth since there's now a little bit more competition in the game. Mm. So you see the Mercs and the Bionic teeth are new.
Are these available now, or are they very soon?
Very soon.
Very soon,
right.
Okay.
I think it's just going to be stocked.
Probably just beginning of 18, maybe.
Right. And the I've seen the Mercs software, and we just had a training about this, but the full release is going to be with the next software updates, and So there's going to be a newsletter being sent out once it's on.
Okay, so and when somebody buys the Denture software, do they get all these workflows?
Right. Mm-hmm. It's
Okay,
one starter kit, and you need a software license for Mertz, of course, for the Baltic Dentro system.
Okay.
But you only have the 98 holder, what you most likely already got with your machine because it comes with a 71 and 98.
Yep.
So you already have that in house. You need a deflow holder which holds those teeth.
Which somebody would have with the Poly
Right.
system already. Yep.
And the Baltic Dentro system has also again a slightly different holder. It looks like a 98, but it has anti-rotational notches on it, which same thing, one-time calibration. Holder's married to your machine,
Got it.
and then you can go.
Sounds like we maybe should do a whole webinar on just these workflows.
Yeah, this is a big topic, and we could talk a long time on this. Yeah, and you can see now here on the basal adaptation that has changed, and on the Vida a little bit. It's a different concept.
This is the one that came out originally, really. This workflow where it was
right.
It's milling the wax base. It's traditionally processed after you do the setup and the try-in, right?
Right, and the cavity is going to look a little different on the Vida ones, but it's also not redeveloped, but changed and updated the strategy to that those newly milled teeth that are perfectly fitting into the resin base. On wax, you always have a little bit of that.
Right, you can play with it.
You can play with it a little bit. On resin, it needs to be perfectly precise.
That's the tricky part for sure.
Right.
Great.
Yep.
And this is the new
This
Vida.
is the new Vida Ionic, and you see it's the same. I don't know if you actually can see my mouse, but I hope so. It's actually the holder.
The same holder that the original. Mm-hmm. Good.
And this is you've seen the dimple on the other picture, and here we see the conical shape on those.
And the software understands as soon as you pick
Right.
that library, it knows to look for that
knows
too.
exactly.
And it sort of takes a lot of these sort of thinking points out.
Mm-hmm.
You just have to decide which system you want to use, right?
Right. And well, not only that, we are getting a variety of teeth to choose from, but also it comes with new setup concepts. So there's going to be crossbite possible with the Vida, and a Girrbach concept being possible. So yeah, you're getting really into it, into the fine details of it, and you get a lot of choice. And I think that's a good thing, that you can choose your workflow, which is right for you.
Good.
You see the three blanks here on the picture, the white wax, the Vida Ionic resin.
Yeah. Removables, or partial removables, I should say. So there's a couple parts to this, right? So the milling machine, and when this comes out, it's going to be able to mill the frame.
Right.
And I'm assuming this is sort of like a peak, sort of acetal, flexible, partial type resin. And then it also mills the pink tissue. And then the card, is that a card as well?
So this is a little sneak peek. So I'm not quite sure if it's the Herrero's teeth or the Mertz or which one have been used. Looks like the Herrero's to me, but yeah, it's the ventral teeth in the card. And you're right, it should be either acetal resin or maybe it could be a peak. I think that's what that might be.
Yep.
And I thought we had the three part.
Yeah, it got combined into one.
Yeah.
But it's 3 layers. It's all milled, which is really interesting.
Correct.
Previously, we usually see removable denture or partial removable denture software where it just produces the frame.
Right.
And you process it like normal, where you pack the acrylic and then add the denture teeth traditionally.
Right.
Now, if somebody does have that traditional workflow where they just want to mill the peak, that's possible. Just that frame in this too, right? So if they don't want to do the full partial denture digital workflow, they can still do sort of half and half.
Right. In the beginning, the partial design software will be released, and then on basically how you are going to process it, if you're going to print it, if you're going to laser sinter it, or what you're doing, outsource it, right? That's up to you. And then the second part, then Amann will release the milling strategies for it and the full workflow. So
okay.
It's a 2-part release.
So this is probably 2018 as well.
Right.
Good.
I assume maybe late 2018.
Yeah. So this is our demo time. So we should show the software first, and then maybe we'll pop the fixtures out and show how that all sort of works and all the parts and pieces.
Right. Let's have a quick peek if there's any questions so
Sure.
far coming up. But
Any questions, Robin? Wait, there's that one up here? Is this super small, this
yep,
window?
it's super tiny. Let's see if I can bring this out here. Maybe that's better.
There you go. Milling versus printing in the near future. Near future, I think milling is the one that's going to be developed first. It also depends on indication type, right?
Right.
There's some indications that are just naturally better for printing, but for long-term use products in the mouth, like dentures or partial dentures and so forth and so on, I think the material science in 3D printing has a long way to come. From everything that I've seen in 3D printing, which I really love and I love following, it's definitely the future. I just don't know short term if it's the future. I think we'll see some real permanent indications in printing probably in the next 5 years. Everything permanent that I've seen so far, it seems like a really good step forward, but it's either not that beautiful or it's got a little bit to go. And actually, I sort of see it similar to when zirconia first came out in like 2004, 2006. Like, it was really good as a strong frame where you had to cover it up with porcelain to make it look pretty.
Right.
And it was a metal alternative, and it took years for zirconia to be where it is today. I mean, that's 10 years now. I think printing, it won't be as long as 10 years to get some of these permanent indication types from today, but it still has a long way to go.
Right, I agree. That's pretty much from what I'm hearing as well. Good example is splints. One of our indications is splints. You can make a retainer or TMJ light splint, and from what I'm hearing, the milled PMMA lasts longer, much longer, but compared to the printed one. Yeah,
well, it's chemistry too, right? When a giant machine is pressing and doing the chemical mixing and everything else, and they're making just like this huge blank factory, it's a lot different than, all these printers are really two-part resins that are like cured, which, they're incredible, of course, but I think they've got a little bit to go.
Right, but and sometimes it's maybe not necessary for a long time. So, for example, we're looking here at some printed models which came out of our model builder. They are based off an intraoral scan, and we just printed them out. And well, you don't really need them to be long-term stable, and you're being more cost-effective with a printed model versus a milled model, even though we can mill a model with our machine as well.
Yes, and I think that's a good point, because like printing a model is a perfect example of what makes sense printed. It doesn't go in the mouth.
Right.
It is custom and has like fine details. It would take forever to mill something like this, and the cost would be a little bit more than printing. So, yeah.
Last question is, what's the difference between HD and fine milling? I noticed with my recent HD update, fine milling was new on my system. Yeah, that fits perfectly, I think, into the demo of the cam part. I can show and explain that right there.
Perfect.
A little bit.
Right up your wheelhouse.
Right. Before we get into the cam, let me, for the folks which don't know the system yet in the detail, let me just see, I can close all these windows here.
So, and again, anybody who's viewing at home, you have control of the windows and the sizes. So we're going to be showing a demo here. So I would maybe make our beautiful faces a little smaller and then the screen a little bit bigger.
So we're looking at the database right now where everything is getting started and going. And it's, of course, where all your customers are and your clients, but also where your settings are establishing over time with each case what you're doing. So you could, of course, just use our default settings out of the box, but eventually your understanding from a good fitting crown is different. And if you're asking 10 people, you get probably 10 different answers. And ultimately your client where you're delivering to has a different understanding than you maybe eventually as well.
And this is the Ceramill Mind software, right?
Right.
So setting up cases.
Ceramill Mind database, correct. And each indication, material, and processing method has its own value saved for each client. So if I make a full contour crown made on a motion to DNA in zirconia, say the solid FX, multi-layer, then I can specify fitting settings, cement gap settings, minimum thickness, etc., all according to my client and what the client expects. And this is going to be saved and pulled up automatically for all those full contour, motion to FX multi-layer crowns for this specific client. And I can have completely different settings for another client. And
so it's doctor specific.
Right, and it evolves basically over time because you make a crown, you get the feedback, you're tweaking the settings, and then it's specific for each client and material.
And prep style probably makes a really big difference.
Right. Yeah, so it's easy. We, if I make a new case here, we would have to fill out just on the left-hand side what it is, the client, the name technician, and then once we have one selected, we get a list of indications, and that's pretty much similar to what we looked at on the real versatility already. You get the full list of indications and the basic indications, and of course you can get updated modules for implant module for the FTS, as we spoke over, etc. So you see the indication list on the left, and then once we pick one, we get a material overview, which is based on the machine selection. So if I'm selecting a Motion 2 5X, you see the list just gotten a little longer.
Oh, I see.
And it's listing all the materials what the machine is capable of. Once I pick one, let's say the FX multi-layer, those are those settings. See, this one was previously saved for this doctor, this anatomic crown and material.
I would probably do a little bit more thicker than that, personally.
That is right. It's just an example. Our default is point recommendations.
0.4 is not recommended.
Right. 0.6.
Yeah. 0.6 at least. Obviously, the doctor will give you what they give you, but 1 millimeter is always preferred.
Right. I clicked on reset to default values, and it jumped up to 0.6.
This is nice. So you get the gingiva. You can add gingiva right just based here, and you can maybe implant based.
Right.
So split file.
Prominent crowns,
or screw retains,
correct. And of course, there's even more advanced parameters for you to specify. And then I have loaded one of those full arch cases because I think it's kind of cool showing the cutback library here where I can zoom in a little bit better at the different types. So we can either have a labial shield on it where
the incisal that's full zirconia.
It's all covered and in full contour, or where we have a cutback on it like that. That's a good time saver. Yeah.
So what does it look like when this file comes into CAM? Or I'm sorry, do you have anything else to?
No, this is perfect. So it's all tying together. So from my database, going back there really quick, I could have now here on the right-hand side, the action side, where the Ceramill map is our scanner. This tells the scanner what to do. After that, I go to the Ceramill Mind, the CAD software. I'm doing my design. The wizard is walking me through the steps.
Fully integrated.
Fully integrated. I get an advanced export mode where I can go into even further details in it. And I can finish the case. It's one workflow. Do all the designing, or do all the scanning, and then do all the designing, and then the files are being in the queue and in the milling. Or I can go from A to C through the workflow.
One case.
For just one case and finish one after another. That's up to your preference and just gives you more options on how you want to do your workflow. And let's say this one here is done. I could go to proceed to production from right here.
This is just the viewing software here? Or was that?
That was actually CAD software, and I now basically opened the wizard up, which brings me now to my CAM portion, to my nesting.
Got it.
And due to the material we selected, it's actually by design. It's showing me here that this was designed for solid, which makes sense. That's the 1100 megapascal for this case. It would even give me a color if I would have chosen it in the height also. So it hides all the blanks where this would not fit into and where it wouldn't match the material. And of course, I can change it. I could get rid of the filters. And I can change to any material, and I get a bigger list here. And I can move it into a different puck if I wanted to.
Mm-hmm.
So it's analyzing here the heights and giving me an estimate where it could fit in. Of course, I can look at it from different perspectives.
So those are your angulation of screw channel holes?
Right.
And I believe the max angulation for the machine is 25%, or sorry, 20 degrees?
Good question, good point. The machine limits are 30 degrees
30, okay.
plus and minus, but it has a small value reserved for simultaneous milling on the internal, and that varies. That's a dynamic value. It might be 5 degrees on one unit, might be 12 on another.
Right.
And it actually changes the inclination and the tilt in the software for you according to the machine limits.
Right. And it also gives you as best of origin as possible.
Right.
So it can tilt and go negative or plus or whatever you want to.
And if I'm using your control, the left mouse, I can actually tilt this, and you saw it was 17.54 before. I can actually tilt this, and I got it on 1639 now. If I spend even more effort, or if I say I don't need this part here on the bottom, you can just nest it anyways. As long as it size-wise fits in the puck, the vertical, something sticks out, it's up to you if you want to still proceed with it.
This is very important if you're running up against a disc height, say 20 millimeters or something, where it's actually, that's great.
And potentially I could even squeeze that in the smaller size puck if that's the only thing I have on hand.
So we've only got a couple minutes left, but do you want to show us really quick how to add sprues in the sintering connector on this bridge? Because I think that's an important part with these advanced indication types, is making sure all those parts and pieces.
Let me load this blank here. It already has a unit in there. It doesn't really matter which one it is. And I can show how to create the stabilizer maybe and how to add the sprues. This is already a calculated file. Let me just remove this one so I can show it on this. So the stabilizer is already created. That's a dynamic stabilizer what's created. The sprues, we can just change the connector here on this button.
So
move it around.
Just click and drag it around.
Delete it with control click, drag a new one out there. With shift we can change the angulation of it, and we could affect the diameter here, make it thicker just by clicking on it.
Oh, nice. And there's a lot of best practices for these types of bridges specifically, which we can't really get into. But
we can make a pre-cut of 50%, or we could make a 100% cut.
So at the end of milling, it'll partially remove or fully remove. Yeah.
And there's two options. One is basically the reduction of the diameter is always in the center of the support pin, and the 100% is usually then at the anatomy. And the stabilizer is dynamically created based on where the screws are set. So if I wanted this smaller, I could just get rid of those screws, remove the stabilizer, and recreate the stabilizer, and I get a smaller one.
It's pretty quick.
Yep.
And it follows contours pretty well, it looks like, and that's quick and easy.
Yeah.
Automatically comes in with the rear stabilizers, 50% cut.
Right.
Of course, you want the internal, or labial side with the sprues left on, so it stays in for sintering. And every other unit automatically comes in. A big mistake a lot of people make is they'll sprue every unit, but it's actually better every other. You don't want to overdo it. Let's see, should we remove a fixture really quick since we're running out of time? Sorry, everybody. Maybe we'll have to do another one of these series, maybe specifically in the mind, specialize it a little bit.
Yep. So I just went to the machine software, the Ceramill Motion, and said deposit tool and change blank order. And this will now pop this window open where you can see all the different holders what we got. There's currently 7. Like I said, there's going to be a number 8. I guess it's going to be for the bolting Dentro system. And here's the set holder for the teeth. And the, let's change to the 98 maybe.
Okay.
So I'm going to say okay. And
so it has all the tools specific for this blank holder. So there's never mixing wet dry. Are we ready to go?
Ready.
And to remove it, comes with this torque wrench, but it's just one screw. Just like a normal screw. Unscrew it. Oh, I didn't do it enough. They make it so easy you almost can't even mess it up. I mean, well, you could if you want to, but it pops off. The fit is very, very good, and you can actually see, I wanted to show this anyway, but we've got this one right here is the Ceric adapter. This one is the Amann Girrbach fixture, so it's a little more flush. The software knows that, right, when you're switching back and forth.
You're selecting if you want to use the adapter or not.
So I'll put this fixture back down. So the grinding tools are part of that fixture. Again, the screw side is going to come out to me, just like I took that one off. And I would probably have the material already loaded in when I did this switch, but in this demo we're not going to. You can always do it in the machine as well, but you tighten it, and it is a torque wrench. So it clicks once, you're in, you know it's at the proper torque. And then last part I'll show is so with the dry bulb. This is there's actually two bulbs. This one's for wet, which has no suction on it,
nice.
And this one's for dry, which has the suction. So you know you're going to have the dry material being evacuated. And the machine knows when this is in place. It knows everything is good to go. Tools are in place as well. And if you were doing an S-retained bridge, it would take it off from there.
Right.
Really pretty easy.
Mm-hmm.
And
I'm just going to say close, and it's now changing, picking up the tool. It's also measuring the tool length, and if you would have by mistake the wrong tool inside, it's actually erroring out, telling you the tool's too short or too long.
yes.
So you cannot by coincidence mix up the carbide burrs with the diamond grinders, for example, because they're shorter.
Yeah, I hope everybody can hear us all right, but
yeah, I hope everything was understandable.
yeah.
The last thing what we wanted to look at is the question about the fine option, and that's the undercuts basically for those cases required. We always have undercut areas here on the emergence on those cases, and therefore we would want to do for undercuts fine.
Oh,
HD.
I see.
That's just going to be the difference
The tool.
of the 5-axis mill and then the tool size, correct? So the HD
So
is going to be a different, smaller one.
HD is really going to get in there and get all those, pretty much is what that means.
Right.
And fine is if you it's a little bit quicker probably
Right.
to mill it out, and if you just wanted this thing out as soon as possible. Thank you, Richard, for coming.
Thanks for having me.
Thank you, everybody.